Hi, in this video we will see how one can bring in the integers modulo prime number into the theory of linear equations and system of linear equations. Well, remember that when we have a linear equation, we have assumed that the coefficients and the constant term are also values of the variables are from a real line. Yes, so we are taking them from real numbers. What we can replace real numbers by integers modulo prime numbers. So p where p is prime. Something like z2, z3 and z5 and so on. So if we assume such thing happening, then we say that the equation or the system of linear equation is over zp. So if the coefficients and variables of a linear equation or a system of linear equations belong to ZP, we say they are over ZP. This fix says what kind of numbers we are working with these guys. ZP is being finite always gives us an option of finding the solutions by just evaluating, because you see the solutions are exactly the definition of solutions as before, but the number of solutions for coefficients coming from ZP is just finitely many. ZP to the power m has p to the power m elements. So solutions, since ZP to the power m is a finite set, one can check one by one elements to find all solutions or set of solutions of a system of linear equation or just a linear equation. For example, find all solutions of x1 plus x2 plus x3 equals to 1 over z2. Means what? Means that consider all possible values for x1, x2, x3 on z2. While there z2, remember, has only two elements, 0 and 1. So plug in all the possible values. So x, y, and z all can be 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, or we can have two ones. What else? Yeah, okay, and then all three. Well, we can plug in one by one. So 0 plus, let me do this thing here like this. 0 plus 0 plus 0 is 0, not equal to 1. So this is not a solution. 1 plus this this will give us, well, 1. This is a good one. This is also a good one. This is also a good one. How about this one? Well, 1 plus 1 is 2. In Z2, well, we don't have 2. It means it is 0. Okay, this is not. How about this one? Again, this is 0, not 1. So this also fails. How about this one? Again, 0. How about this one? 1 plus 1 in Z2 is 0. Plus 1 is 1. So this is also. So here what we did, just by checking, by solving all the possible values, we saw that vectors 0, 0, 0, and no, not 0, 0, 0, when there was one of them 1, okay, 0, 1, 0, and 0, 0, 1, and all ones are all solutions for x1 plus x2 plus x3 equals to 1 over Z2. Well, for Z3, you plug in all possible values for x1, x2, x3, and you find all the possible solutions. Or even if you have a system of linear equations, something like x1 plus x2 plus x3 equals to 1, and x1 plus x3 is equal to 0 in Z3. Well, this means what? This means that we have 3 possibilities for x1, 3 possibilities x2, 3 possibilities x3. There are in total 27 possibilities for these ones. You can plug in one by one and check all of them. For example, we can see that some of the solutions, all of the solutions will have this kind of pattern. If first component is 0, the last component is going to be also 0. Well, what about middle one? We will check those ones. If the first one is 1, the third one will be 2. And if the first one is 2, the last one is going to be 1. So these are something, well, you can do one by one, check all of these things. Now, 0, 0, 0 is not a solution because it doesn't satisfy the first one. Add zeros, you get 0, it's not 1. 0, 1, 0 is a solution, so this is a solution. Is there any other possibilities? No, if I put 0, 2, 0, add them, you get, wow, I don't like that one. And how about this one? 1, 2, and then, well, this will be, there will be only one possibilities here, and there will be only one possibility. You can check these ones one by one. So there are 27 possibilities. You plug in all of them, and you will see that these are the only possibilities. There are only 3 solutions for SLE, for this SLE. When it comes for the system of linear equations over ZPs, this is just very easy way of dealing with those ones, but we will learn that we can do exactly whatever we do for regular system of linear equation. We can apply those ones to these systems also. So this is basic work that you can just plug in. Well, we have to consider something like if this is x1, x2, x3, 3 variables. Let's say in Z7, we are in big trouble. Even in Z5, it is 125 elements that you have to check. This is a big thing. Well, as it goes up, you will get more and more problems. So you will be able to do whatever we do for the regular system of linear equations, for the system of linear equations over ZPs. This is something that we will learn in the next section.